Hello everyone. In this session, we will be seeing a type of commands in MySQL and do some hands-on with that. So main reference that we will be using is MySQL reference documentation, which you can find from the official site, MySQL 8, which is the version that we are using. So I will just give an overview of where you can find things that you need, things like that. So basically here you can see installation and upgrading we already saw in previous session. There you can refer to if you want to install for Windows or Mac, things like that. And there is a tutorial session here. So which will have how to enter queries, things like that. So basically I just skip that. You can go through if interested. So we'll be focusing on maybe around here, data types, functions and operators, SQL statements. And this coming down something like stored objects, that kind of things. So mostly we will be initial part, we will be covering these three. I will not be going in this order because a more suitable order will be data definition statements, followed by data types, followed by data manipulation statements, which in turn will be followed by functions and operators. So I'll be following that order, but more or less the content, if you want to go in more detail, you can refer to this. So I'll just open my Workbench also. So we will do with the GUI itself, since that will be like more easier for you to understand. I can do in shell as well, but that way you may feel like a little overwhelming. So we will go with the Workbench itself. So basically we will switch between tabs. You can connect the database instance. To ask for the password. Our password is data science. Okay. So basically you will get a query window, and if you remember, the last query that we did in a previous session was show databases. So actually two like lightning symbols you can see here. One will execute all the code in this whatever file we are seeing. The second one will execute the query on the line in which the cursor is there. We will be only using that, and the third one you can use to see how the query executes. So basically four databases you can see here: information schema, MySQL, performance schema, sys, which are the default databases in MySQL. So basically first part, for comments you can use either hash or two hyphens. So we will be seeing what is called DDL first, or in other words data definition language. So SQL, as you can see, stands for structured query language. And SQL components we can actually split into different parts, like DDL for data definition language, then DML all starts with data, so I'll put the middle parts alone, for data manipulation language, then DCL for data control language, and TCL for transaction control language. So basically these are like subsets of the SQL language. These are not defined by the standard. Different vendors may call these different ways. For example, if you see MySQL, they are like dividing the statements into DDL, data definition, DML, data manipulation. Then our TCL that we saw, they are defining as transaction locking statements. And whatever we saw in DCL and other commands, they are mapping in database administration statements. And they have additional 2-3 replication prepared compound utility. So basically whatever I am telling here, this DDL, DML, DCL, TCL, etc. are like more comprehensive definitions. Depending on each vendor of the database, there will be separate subsets. So we will be seeing these, we will be seeing the first DDL and DML alone. DCL and TCL are slightly advanced concepts. We will not be seeing as part of this data science course. Later, if I get time, I will upload some videos. If you are interested, you can go through that also. But from our data science point of view, only the DDL and DML statements matter to us. So the DDL statements that we will be covering are create, then alter, rename, drop, truncate. So create, alter, rename, drop, truncate 1, 2, 3, 4, 5. 5 are the only DDL statements available in MySQL. So with that you can do what we call a schema. So schema basically means a scheme of things, right? So the scheme of the database that you want, and each database will have tables in that. So that scheme of tables as well. So the schema includes the scheme of the database that you want as well as the scheme of the tables. So all that we will be defining using this set of 5 DDL commands. So we will in this video we will see the DDL statements, and DML, DCL, TCL we will see in further sessions. So I'll be doing everything in a single file, so that finally same file I will upload into the GitHub repo also, so that you guys can refer to it later. Now coming to create part. So what all I can create? So basically as we saw in schema, we need to create a database, right? So once we create a database, I need to create tables in that which will actually contain my data. So I will come to tell with an example what each of these means. Then these two only we will see for the time being. Actually, there are more things like views, function, procedure and all. Those we will not see now. We will try to do only with restrict ourselves to database and tables. So along with our show databases, so we can just try to create. So what we want to create? So we want to create a database. Then you have to give a name for that. So name we are simply data science. So we will give it the database name as simply DS with a semicolon. I will just execute that line. So query completed, I got one output. This is not having any output, so that is why output window did not come. So now again I will just run my other query, show databases. So that will show me one additional table, simply DS. Now I want to go inside that simply DS and do things inside that, because otherwise with each query I will have to tell that you have to refer to the simply DS database. So to avoid that, I can use a utility statement use to tell the SQL to map all the queries to the simply DS database. So I can run that. So query is completed. Now next thing is database is created. We need to create tables inside that. So let's see what our example that we saw in the group introduction session. Let's first try to create a table which holds the height of all the people in the world. Right. So how I can do that? So I need to, like as in previous session, create a table. Then table name. Table name I will tell as height. Then I need to start a parenthesis bracket and end it with a semicolon. And within this part, I have to define what are the columns that I want in my table. So basically, table is like a two-dimensional structure having rows and columns. So the rows will consist of my data and columns will be like headers. So in this case, I will have to have the height of the people as my column name, and inside that I will have to have the data depending on the height of people. So let's name it as, first we have to give a name for that. Let's name it as individual height. So then we need to tell the SQL what is the type of the data. So that I will just cover now. So there are different types of data. Any programming language that you see, it will have some syntax and semantics, and data type is one of the most important thing. So as you can see in our this thing, height is like a numerical data type, right? So numerical I can have what, integer, right? So SQL actually supports different types of integers. So we will just stick to basic. We can go to the reference documentation. So from that data types, you can get numeric data types, data types, string. Those three only we will mostly covering. So you can get more details of all the types. So for the session, we will just be covering the basic things. So integer whatever is required to run your queries, right? So integer int, then different types of integer are there. So I will just put dot dot dot. Different types are there. Then fixed point. Fixed point means that it is basically a decimal, but it will be exact. Like let's say I will define it as decimal, and there are actually numeric type also. So you can name it as decimal or numeric. So we will basically define it as something like decimal 52. It means that I am suppose I want to represent 23.30 00 or 15.21. Then I have to use that total for like 5 places will be allotted, out of which 2 will be in the decimal part. So I can have even again 15.21. Okay, sorry, or even 121.34, things like that. And if I give like 53, then I can have only like 23.000, 12.01023, things like that. 3 decimal points I can have, but in my number units part and tens part only I can have. So like that. So that like I can represent decimal places to exact. Now if I can use like floating point values also, but that will be like approximate. So that same as other programming language, it will support float and double. And in addition, I have a what is called a bit value in case I want binary numbers or binary data, like something like true or false kind of things. I can have like of size n characters, like n characters or n numbers, right, which are either of 0 or 1. So these are the different types of data I have in numerical type. So I'll put 2 more hyphens here to differentiate. Okay, so you have to either tell which type your data being. So we can just go with the type int. And so we will, since we are dealing with numeric data, we will only see this time. When we go to more data, we will see other types also. Okay, so next thing that I can do is, do I want a particular length or not? Things like that. So we will just do with this. We will try to run this. Okay, I try to save it. Okay, we'll save later. So once I ran, it showed me that query is completed. So let's try a show tables command, which is a utility command. That will tell me that there is a table named height. And let's say some more statistics. There is another command like show table status. So that will give me additional information, or like which database engine it is using, number of rows, row length, data length, etc. So since my database is currently empty, it is not showing anything. So one thing to notice that it gives rows count here, but it will not be the actual count from the data. It will be like what is used by the optimizer inside. So we will see that when we go to like more details. So now we will just one problem that we saw is basically you want something to identify to which person this height is mapped, right? So we did not have this here. We only had some value corresponding to some height of people. So I would like to add something like a person ID or individual ID to this, so that I can have again as integer type. So then I can just if I try to run that again, it will give me an error. Query interrupted, like that you will get if it is an error. Why it happens is that because you already have a table called create, which you did with a create of name height. You are trying to again redefine the table. So 3 things you can do this. One is like you can like drop table height. So which is, as I told earlier, another DDL statement, as we wrote somewhere here. Yeah, drop. So you can do that before running this second query so that okay, I'll run that drop table height, query completed. Now let's try to run this. Yeah, query completed. Now if I show the tables, it is still there. Yeah. Now one problem here is if I try to again drop it, query completed. But if I try it once again that gives an error. So I need to tell you that do a command only if it exists. So that way I can specify with if exists. So that way the query will get completed even though the table is not there. As you can see, the table is not there, but my drop command will not give an error. So similarly here you can tell like if not exists, so that this table will be created only if it is already not existing. So these kind of things can like avoid the common database errors that we'll have. I will run this again, show tables. Okay, so again the table is there. So this create and drop. So drop will drop the entire table. And with the create I can add the new integer I added. Now there is something like I added integer ID as well as integer height. So like in our example 160, 161, 162, 140 like that, I can interpret the height of people. Now suppose I need now one thing problem with this is this will accept null values also, that we will come into later when we try insert and all, which are DML statements. I will come into more details of that, but we will complete this and go. So basically we need to tell it whether it should accept null values or not. By default it will accept null values. So to tell that null values need not be accepted, I can tell that this value should not be null. So similarly height I can tell that it should not be null. So that way I can inform the SQL that these tables needs to have some values. Now suppose I want it to be, in addition, the values, I don't want the index integer ID to be repeated. So then I can go for what is called unique. So that means that the integer ID should not get repeated. So whereas for height I cannot go like a unique statement because height will get repeated, right? Then actually over each table you need something to uniquely identify each row. So that is what we call a primary key. So the not null and unique combination is what is the feature of a primary key. So since we want the table to be not null and unique, I can replace that not null and unique by primary key. And when a table is created, for looking up the entries, an index will be created and index will be based on the primary key. So that way I can define my primary key not null, and this much will do for our. So I will again drop it and I will insert once again run it. Query completed. Okay. Now also no rows are there. Okay. And we have not seen where data is there, whether data is there or not in the table. So now we saw two DDL statements. We have some more remaining, rename, truncate, alter and all. So rename is I have height, and inside that I have this this individual height. So I suppose I want to change the name of the table. So I can tell like rename table height. I'm not sure of the syntax. Let's just check the documentation of rename, whether it uses as or not. I'm not sure. Let's just check. Rename table. We will go. So this is something that we can always do, right? When we are doing trying hands-on, we can always, yeah. You will have to give all table name to. It is not with, yeah. Rename table height to, let's say height all, height all, something. Okay. So let's see. So once we run that, query is completed. Now if I show the tables, that will give me the new table height all, right? Now if I again create a new table, again old query I run, then if I run again the show tables, you can see that now two tables are there. One is the first initial table that I created corresponding to now renamed as height all, and the table that I just created new one. Since I have given two names, both those will get created as two different tables. So we will just drop that we will proceed with height itself. We will drop our height all table. So in case you want to query in between, I will just put this also in between so that if you try this out file, you can get similar outputs. Okay, so we are done with 3. Now truncate we will be seeing after we fill some data into it. So because that only will be like you will be able to understand. So once we see some DML insert, then we will see truncate. So just keep in mind that truncate is another this DDL statement. So now we will see alter for the last part. So let's try it here. So now suppose I want to change some feature of this table. Like I define some 2 rows, and now I want to add a new column, or I want to change the data type. So I will just drop the height sort table. I have not run that query yet. It is completed. Now I will show the tables. Okay. Now just before going to alter, let's try one command called describe. So describe table. So table name describe height will show me what are the fields or column IDs, type of the column ID, then whether it will accept null or not, and if we is it any defined as any key or not, then any default extras that default also will come. Okay, suppose I will tell that also and then proceed. So let's drop it once again, or I will create this itself, then alter that. Yeah, that will be better. Okay, so we will describe height here. So we will try to add one more column to this with the some numerical description, not null. So let's run that. And once I run the describe it, again I saw that additional column is added with type integer. So that way I can use the alter command. And there are some additional like fields, so that will come in a later video. I will go into details of syntax of each of these commands after seeing DML also. Like we will see DDL in more detail. So that's all for the current session. Thank you all. See you in the next session. Arun here signing off. Thank you.